Hi, I'm Richard Kyles, Principal Consultant with General Data Tech. I wanted to take a minute and go over the differences between a virtual machine and a container. First, it's important to note that a container is not a VM. This is very common. You might hear somebody say, oh, a container is kind of like a virtual machine, but it's really not. That's basically like saying an airplane is like a train. Yeah, they both might carry stuff, but they do so in completely different ways. Well, virtual machines and containers are the same way. They both run applications, but they do so using completely different underlying architectures. When we look at a container, it's really meant to run an application, and that's typically a single application. Whereas a virtual machine is meant to run an operating system. It virtualizes an entire computer for an operating system to be installed on top of. So let's look at this in a little more detail, and we'll start off with virtual machines. So this architecture might look pretty common to you. It's something we've been using for over a decade now. We start off with a physical layer of hardware. We install some type of a kernel on top of that. It might be a Linux kernel or a VM kernel if you're running ESX, or even an NT kernel if you're running Windows. On top of that kernel, we have our host operating system, it's file system. So that's the file system that we install applications on top of. Now on top of that, we have another layer of virtual hardware. And this is where we start getting into the virtual machines and how they differ from a container. So we have our hypervisor. Within that hypervisor, we have a virtual set of hardware that we're utilizing. Then we also install another operating system kernel, either Linux or Windows. And then on top of that, that kernel has its own file system. That's what we refer to as our guest file system. And then we have additional applications that we install. So when you look from the applications within that virtual machine's perspective all the way down to the physical hardware that data is being transmitted over, we have a number of different layers that we're actually cycling through. Now over time, virtualization has made some vast improvements. They have the hypervisor running directly within the kernel now. You still have some applications outside of that start and stop and manage a VM, but the actual hypervisor itself is now a kernel module in most cases. So that helps on some of the performance issues that we used to have. We also have the capability to let an operating system, a guest operating system, know that it's running as a virtual machine. So it can make calls directly to that underlying hypervisor or to the underlying host kernel instead of having to emulate a lot of those system calls. And we even have the capability of passing I/O or inputs and outputs directly through down to the underlying hardware in some cases. This is common when we look at TCP offloading, let's say, on a virtual NIC. But we're still packaging and running an entire operating system within that virtual machine platform. When we look at a container, instead of virtualizing a whole operating system, really what we're doing is we're only packaging an application. So you can almost think of something like Docker or a container as being an application launcher. You can really look at it like that. When we launch a container, we're really just launching an application. We're taking an application that's been prepackaged with all of the libraries and any type of system files that particular application needs to run, and then we're launching it on top of our host kernel. We're not virtualizing anything. We're not virtualizing underlying hardware. We're not installing another operating system. We're not utilizing separate drivers or software-based drivers. What we're doing is launching that application, and we're using that underlying host kernel to do so. Now that's an important distinction between the two. That's why we say a container is not a virtual machine. It's really not. All we're doing is starting an application. Now let's take a look at that in real life. If I do a Docker run, we're going to use the -IT switch. That means it's an interactive pseudo terminal that we're running. And I'm going to use our CentOS latest Docker image. I'm going to run a uname -a. So basically what this says is I'm going to use Docker, I'm going to run a container, I'm going to say I'm going to make it interactive, and I'm going to use CentOS image, and I'm going to launch uname-a. And there we go. Now we can see that this is not the typical CentOS kernel, and that's because it's actually utilizing the underlying kernel of that host. I can do the same thing if I run Ubuntu. So let's do a docker run -it. I'm going to use Ubuntu 14.04. We're going to go back a little ways. I'm going to do the same thing again. We're going to launch uname-a. Now you'll notice that I don't have Ubuntu 14.04 running on this system, so I haven't already downloaded or executed that image. So what it's doing is it's going out to Docker Hub and it's downloading that image. So Docker Hub is a Docker registry. We'll talk about that in a later video. But essentially, if it doesn't find that image locally, it will go out and download it. And there we go. As you can see, it's the exact same kernel version that I'm running on CentOS. And that's because I'm not using a virtualized system. I'm not running a virtual machine. I'm simply running an application, in this case uname-a, to identify the underlying kernel that that system is running on. In this case, it's simply using the host kernel. So we're not virtualizing a complete system. We're actually running an application on the underlying host kernel, which means that we can have many more containers running than we could virtual machines, because we don't have the other layers of operating systems or virtual hardware that's associated with a VM that we don't have in a container environment. So hopefully that made it a little bit easier for you. Maybe a light bulb went off. Like I said, you can really think of a container as more of an application launcher than a virtual platform. If you have any questions, feel free to reach out to us. You can reach me at rkiles, that's RKILES, @gdt.com. Thank you.